Proceed to the next topic, which is more about C++ loop statements. As we've already understood, a loop is a program construction that repeats a statement or sequence of statements a number of times. Just like what we did in the previous lessons where we implemented a loop statement. Of course, the body of the loop is the statement being repeated, and each repetition of the loop is called an iteration. There are a few concerns about designing a loop. First, what should the loop body be? Also, how many times should the body be iterated? Which means, whenever we are designing a loop, we must take into considerations the actions that needs to be repeated in a loop and for how many times they need to be repeated. Hence, we will be able to identify and design our loop body as well as the number of iterations that is required. Let's take a look at the while and do while loops. Of course, the following are the important difference between while and do while loops. First, a while loop checks the Boolean expression at the beginning of the loop. In this case, a loop might never be executed. So basically, that's the nature of a while loop. On the other hand, a do-while loop checks the Boolean expression at the end of the loop, which means that a do-while loop is always executed at least once, for the reason that the Boolean expression is placed at the end of the loop. Hence, there will always be a chance for the loop to execute at least once. So let's take a review of the while and do while loop syntax. If we will remember, this is how the while and do while looks in terms of their syntax. As you can see here, we have the while keyword followed by your Boolean expression, which serves as the condition to follow whether our loop body will be executed or not. The same applies for the do while loop, only that the loop body comes first and the Boolean expression is placed at the end of the loop, hence allowing the loop body to execute at least once. Whenever we write a loop, there is always an increment operator that we need to be placed at the right location. Of course, we can actually use an increment or decrement operator depending on the scenario that we would like to implement. If we will recall, we have used this operator in statements such as this one. In this case, we would like to increase the value of number by 1, hence the increment operator. The increment operator can also be used in the following expression. For instance, we have the following. We assign the value 2 to this variable. Then we also have this variable which involves this variable being incremented. If we are going to evaluate this, what will happen is that this particular increment operation will first return the value of the number, which is 2, to be multiplied by 2, then increments the number to 3, which means if your increment operator is placed after your variable, what happens is that the value of the variable will be used first or returned first before it will be incremented. Moving on, We have the following scenarios of using the increment operator. It's either we place the increment operator after the variable or before the variable. But what is the difference between the two? On the first scenario, like what we saw in the previous slide, what happens is that it returns the current value of the variable, then increments the variable, in this case, the variable named as number. An expression using this kind of increment will use the value before it is incremented. On the other hand, if we are going to place the increment operator right before the variable, what will happen is that it will increment first and return the new value of the number. Hence, an expression using this kind of increment will use the value of the variable after it is incremented. But of course, both of them would have the same value after the increment operator. Here's an example. In the first example, we are going to use the increment operator right after the variable name. What will happen is that the number will first be returned with its original value and of course multiplied by 2, and after which it will be incremented. Hence, if we are going to output the result of the operation, it will give us this. On the other hand, if we are going to use this kind of increment operation, what will happen is that before we multiply the number by 2, it will first be incremented. Hence, this will become 3, then return and multiply to 2, giving us 6. Although, right after the increment operation, both of them will have the same value of 3. How about the decrement operator? Of course, the decrement operator works the same way, only that instead of adding 1, what it does is it decreases the value of the variable by 1, hence the decrement operator. Of course, we also have the same scenario of using the decrement operator, whether before or after the variable. Of course, it would have the same result, like what we've seen with the increment operator. Now, let's proceed with another example of a loop statement. This time, we are now going to explore the for statement. A for statement, or commonly called a for loop, is another example of looping in C++. It is designed for common tasks such as adding numbers in a given range. And for such application, we might find that it is more convenient to use than a conventional while loop. Although there will be times that using a while or do while loop would be more convenient as compared to a for loop. Of course, anything that can be done by a while loop can also be done with a for loop and vice versa. Now, let's compare the two. Here's an example of a while loop. As you can see here, we have the following variables. The variable that will be updated in our loop body, and of course, this would be this would be our counter variable, which would try to see if a certain condition have already been reached, which will signify the end of our loop. Now, if we are going to convert this into a for loop, this is how it would look like. As you can see here, they do the same thing, and if we are going to look closely, they basically have the same structure. For instance, we can see that they both use the same set of variables. The variable that will be updated in the loop body, such as this and this. Also, we have our counter variable that needs to be initialized, just like this one. And also, the Boolean expression which will serve as the condition for our loop, which can also be found here. And of course, we also need to update our counter variable through the increment operation, which is also present in the for loop version of our example. As you can see, they are basically similar. Let's take a closer look at the for loop by dissecting it. As mentioned, the for loop uses the same components as the while loop in a more compact form, as we have seen in the previous example, such as this one. The first part is called our initialization action. The next one is our Boolean expression, which tries to see if a certain condition has already been met. Otherwise, the loop body will keep on executing. And of course, whenever an iteration or an execution of the loop body has been performed, our counter variable also needs to be updated. In this case, we update our counter variable through increment. Talking about for loop alternative, a for loop can also include a variable declaration in the initialization section, such as this one, which means that we would like to create the variable n of type integer and initialize it with the value 1. And for the condition, it means that it will continue to iterate or loop as long as n has a value less than or equal to 10. Then finally, after each iteration, we need to update our counter variable by incrementing it by 1. Now that we understand how to implement a for loop, let's take a closer look at the comparison of their syntax. If we will recall, they basically have a common set of components: the initialization, the Boolean expression, the update section, and of course, the loop body, as we can see here. But of course, we also have to take note that for a for loop, those components that comes after your for keyword are separated with semicolons, and of course they are enclosed in parentheses. Now let's talk about more of the for loop details. Here's an example in which the initialization and update sections of for loops might have complex expressions such as this one. As you can see here, you can also place expression as the assigned value of these components. For instance, for updating your counter variable, you can actually assign expressions such as this one. That would still work. Also, instead of assigning constant values, you can also assign them with a call to functions, such as this one. As for the for loop body, the body of a for loop can be a single statement, or it can also be a compound statement. But of course, if we are going to put a compound statement in the body of a for loop, that would now require us to place braces. Therefore, we must enclose them in braces. Here's an example. As we can see here, the body of our for loops is composed of multiple statements. Hence, we need to enclose them with braces, such as this one. When we are dealing with a for loop, we must take note of what we call the empty statement. If we will recall, a C++ would interpret a semicolon as a statement. Hence, a single semicolon is still valid statement as far as the C++ syntax is concerned, and therefore will be accepted by our compiler. For instance, placing a semicolon after this increment operation creates the following statement. Thus, placing a semicolon after nothing creates what we call an empty statement. It is syntactically correct and would compile, but of course it would do nothing, such as this one. Hence, placing a semicolon after the parentheses of a for loop creates an empty statement as the body of the loop. Here's an example. As we can see here, this for loop looks okay. As you can see here, we have the following component of a for loop and of course, the loop body. But if we will look closely, we can see here a semicolon. As we mentioned earlier, this is an example of an empty statement. What would happen is that our C++ compiler will consider this semicolon as the statement that is associated with this for loop. Although it would execute this statement which displays hello, it is actually not a part of the for loop anymore because of this empty statement caused by this semicolon, which might be unintentionally placed in this location. Therefore, we must be careful. Talking about variables, the C++ standard requires that a variable declared in the for loop initialization section should be local to the block of the for loop. Therefore, it is important to know how our compiler treats these kinds of variables. Thus, if we want our code to be portable, we should not depend on the compiler to treat these variables as local to the for loop, which means it is safer for us to have our variable declared outside of the for expression. Now, let's decide which loop to use for a given scenario. We must choose the type of loop late in the design progress, because in the first place, the more important thing is for us to first analyze the problem and come up with a solution in the form of a pseudocode. And of course, whatever kind of loop or branching statement to use would depend on what the program will require. First, we must design the loop using a pseudocode, then translate the pseudocode into an actual program. And basically, the translation generally makes the choice of an appropriate loop clear. While loops are used for all other loops when there might be occasions when the loop should not run. And of course, we can also do while loops can be used for all other loops when the loop must execute at least once. So when do we choose a for loop? Choosing a for loop is typically selected when doing numeric calculations. This can be done when we are going to perform simple calculations that needs to be repeated a number of times. This is especially useful when we need to use a variable which changes its value by equal amount each time the loop iterates. And of course, for choosing a while loop, which is the more commonly used, we can use a while loop when using a for loop is not practical. And also when there are circumstances for which the loop body should not be executed at all. And that is the opposite in the case of a do-while loop. We use a do-while loop when a for loop is not appropriate, and of course when the loop body must be executed at least once. And finally, we have the break statement. As for the break statement, there are times that we need to exit a loop before it ends. If the loop checks for invalid input that would ruin a calculation, then it would be better to just end the loop and get out of the loop that is currently executing. The break statement can also be used to exit a loop before normal termination, hence preventing our program from going into a runtime error or a logic error. Also, we need to be careful with nested loops. We use break only to exit the loop in which the break statement occurs. Here's an example. In this example, the program would require us to enter 10 negative numbers. And of course, we have a do-while loop which would monitor the number that we have entered. In this case, our program will only accept 10 negative numbers. And of course, if we entered a positive number, the program will exit our loop. Our program does that by using this statement, the break statement, which means if the number that was provided is positive, then it will execute the break statement, and therefore it will cause our loop to end, which means it will immediately exit our loop. Let's run this program. Okay, let's enter 10 negative numbers. Okay, let's run that again, and this time let's provide a positive number. And this time I am going to input a positive number, and let's see what happens. As we can see here, the program terminated and it exits the loop that we have, just like here. That's because of the break statement, which causes our loop to immediately terminate. At this point, here's a simple exercise that you can do by yourself.